In section 3.2, we're going to be looking at problem solving and some business applications which involve systems of linear equations. The essential concepts for this section include solving problems using systems of equations. We're going to use functions to model cost, revenue, and profit, and perform what's called a break-even analysis. In this section, we're going to take a closer look at how we might use systems of equations to actually solve real-world problems. So, systems of equations and applications, there's a general strategy that we would employ for word problems. In this case, we're talking 4 steps. First thing we're going to do is identify the variables in the problem and use variables to represent those unknown quantities. Then we're going to write a system of equations describing the problem's conditions. We're going to basically translate from English into the math language, into our mathematical expressions. Then we solve the system, which basically allows us to answer the problem's question. And we're going to make sure that the answer that we give is the answer to the question that's being asked, not some other question, right? So you'll get variable answers, but you don't just circle the variable values. You actually need to go back into the problem and make sure you answer the question that's being asked. And then, of course, we want to check the proposed solution in the original wording of the problem. Not only asking does it make sense, but also checking to verify that it satisfies the conditions that are stated in the word problem. Specifically, we're going to be looking at 4 types of problems. The first 2, 1 and 2 here, dual investments and mixing problems, are actually very, very similar in the fact that the techniques that we're going to use to set up the equations are almost identical. And this is a business application, and this is mixing from any type of application, from putting together acid solutions in chemistry class to a jeweler mixing gold alloys to get a certain percentage content of gold. Cost, revenue, and profit, we're going to talk about those functions and how we might use them to perform what's called a break-even analysis. Let's dive right into it, shall we? Here's a problem of mixed investment. Let's say we are investing $7,000 in 2 accounts. One account pays 7% annual interest, the other pays 8% annual interest respective. If the total interest for the year was $520, how much was invested at each rate? Okay, so to begin with, going through our step-by-step process of word problem analysis, we're going to begin by identifying the variables. So let's use variables to represent the unknown quantities. Now, what are the unknown quantities in this particular problem? Well, it's how much that we have invested at each rate. We have 2 different accounts, right? So let's let X be the amount invested in the 6% account, and let's let Y be the amount invested at 8%. Okay? Now that we have our variables established, let's write a system of equations. What's the first thing we know about these amounts? Okay? The first thing we know is that there is a total of $7,000, right? If X is the amount at 6%, Y is the amount at 8%, the total amount that we have is $7,000. Now, how do you write the total? Well, you write that it is the sum of the 2 variables, right? The total equation says that X plus Y has to equal 7,000. Okay? Now, how about the interest? Right? We know that the interest total from the 2 accounts is $520. Let me illustrate this by writing down a table, and I can suggest that you would write this table down in each of the examples that we're doing here. I may not always write the table down, but it helps you to see what we're talking about in terms of the amount of interest that's earned, right? So if you have in account 1 which is the 6% account, right? The amount in that account we've decided is going to be X. Okay? The interest rate is 0.06x. So the interest rate is 0.06, right? So the total earned in interest is going to be the percentage times the amount, or 0.06x. Okay, that's the interest earned in 1 year. Okay, what about for account 2 at 8%? Same thing, right? Except that the amount is Y, the interest rate is now 0.08, so the amount earned is 0.08y. So this is the amount of interest earned from the first account. This is the amount of interest earned from the second account for the unknown values Y and X. Now we want the total of this to be the final amount of interest earned, which would be 0.06x plus 0.08y should equal $520. Right? That's the final amount. Interest earned from the first account, interest earned from the second account. Notice now we have the following system. Together we have x plus y is equal to 7,000, and 0.06x plus 0.08y is equal to 520. There's my system of linear equations, which now we need to solve. Now I recommend that on these, because we have a coefficient of 1 in front of the x and the y here, I'm going to solve by substitution. Remember, substitution from 3.1 says solve one of the equations for one of the variables and then substitute that into that variable in the other equation. So let's solve equation 1. Right? Equation 1 gives us that y is equal to 7,000 minus x. All I did was subtract x from both sides up here. Okay? Now substitute into the second equation. That says 0.06x plus 0.08 times 7,000 minus x is 520. Right, now we've got an equation of a single variable. We just need to simplify and solve for x. Distribute the 0.08 to each of those terms inside. I have 0.06x plus 0.08 times 7,000 gives me 560 minus 0.08x equals 520. All right, combining like terms, I end up with a negative 0.02x plus 560 equals 520. Subtract the 560 from both sides. Gives me negative 0.02x is equal to negative 40. Now if I divide both sides by negative 0.02, okay, we divide this off. The negative divided by negative becomes a positive. Okay, so 40 divided by 0.02 gives me 2,000. Okay, so that says that I have 2,000 of my dollars invested in the 6% account. Now to find how much is invested in the other account, I will substitute x back into here and have that y is equal to 7,000 minus 2,000, or 5,000. Okay, so I have 2,000. The final answer is $2,000 at 6%, and $5,000 was invested at 8% to yield that final amount of $520 in interest. Okay? So getting to the system is sometimes the tricky part, but fortunately most of the examples that we have cover all the types of problems that you're going to see in your homework. You start with a total equation and then the percentage or the rate equation, which is the second equation we have here. Then we go back through the technique for solving by substitution to get our final answer. In this problem, we again have a combined investment problem. We have that we inherited $5,000 with the stipulation that for the first year the money had to be invested in two funds, one paying 9% and the other paying 11% annual interest. So same problem again. How much did we invest in each one if the total interest earned for the year was $487? So start with the variables. What are the unknowns, right? It's how much did we invest at each rate. So let's let X equal the amount invested at 9%, and let's let Y be the amount invested at 11%. Now we set up our equations. First equation is the total equation, which says that X plus Y has to be how much? What's the total amount? It's $5,000. So X plus Y is $5,000. Okay, now what about the interest in this case equation? How much is coming from account number 1, right? Account number 1 is the interest rate times the amount in there, so 0.09 times X. Okay, how much is coming from account number 2? Right, well that's going to be 0.11 Y. That's 11% of Y will be my interest gained from the second account. The total of that needs to equal a total interest of $487. So here's what my system then looks like. It is X plus Y equals 5,000, 0.09X plus 0.11Y equals 487. Now we solve the system. I'm going to solve this system again by substitution. So if I call this equation 1 and this equation 2, from equation 1, if I subtract, say, Y from both sides, I end up with X is equal to 5,000 minus Y. Okay, now I'm going to plug that into equation 2 and get 0.09 times 5,000 minus Y plus 0.11Y is equal to 487. See, all I just did was stick 5,000 minus Y in for X right here. Okay, now I've got an equation with one variable, so I'm going to solve by first simplifying both sides. Okay, 0.09 times 5,000 is 450 minus 0.09Y plus 0.11Y is equal to 487. If we combine like terms, we end up with 450 minus a negative 0.09 plus 0.11 is going to be 0.02 positive. Y is equal to 487. If I subtract 450 from both sides, that gives me 0.02 is equal to 37. So divide both sides by 0.02y. Divide both sides by 0.02. I end up with y is equal to 1,850. Which again, if you go back to our variable list, tells me that's the amount at 11%. So to find x, remember that x is from here 5,000 minus y, which was 1,850. So that's 3,150. Okay, so the final answer to the question is how much do we invest at each rate? We invested $3,150 at 9% and $1,850 at 11%. That answers the question to the problem. Here we have a similar mixing problem. Instead of mixing investments, however, we're going to be mixing an alloy. Okay, a jeweler needs to mix an alloy that has 16% gold content, alloy being a metal solution. One has 16% gold content, the other alloy has 28% gold content, but the desire is to have a 32-ounce sample, 32 ounces of a new alloy that's 25% gold content. So I'm going to take so much of the 16% and so much of the 28% and mix it together so the result has 25% gold content. The question is, how many ounces do I need of each to get that mixture just right? Well, we can do it the exact same way. We just start one by identifying the variables. What are the two things that we need to know? We need to know how much of each, right? So let's let X equal the amount of alloy we need of the 16% alloy, okay? And let's let Y be the amount that we need of the 28% alloy. Okay? Now, let's set up our system. How much total do we want? What's the total equation? Well, we want a total of 32 ounces, right? So if we're going to do ounces as what it's equal to, then these each need to themselves be in ounces, right? So we need to take X ounces of the 16% alloy plus Y ounces of the 28% alloy. The total we need to get is 32. But that's not the only equation. Now we need the mixture equation. Okay, so how much gold comes from the first alloy? Okay, well, it's going to be 16% of however much the alloy I get, right? Because I've got so many ounces, 16% of that is gold. So that would be 0.16x. That's how much gold comes from the 16% alloy. Now, how much gold comes from the second one? That's going to be 0.28y. 28% of the amount that I choose of that alloy is the amount of gold. Now, how much gold do we want? Or how much gold does the jeweler want? He wants 25% gold content out of his 32 ounces, right? That means he wants 25% of 32 to be how much gold he gets, right? 16% of this is gold, 28% of this is gold. He wants the result to be 25% of 32. That is what your mixture equation looks like. 16% of alloy 1 plus 28% of alloy 2 is equal to 25% of the total amount that he wants. Now this, if I just plug that in my calculator, I see is 8. So I end up with the following system of equations. I end up with 1x plus y is equal to 32, and 0.16 of x plus 0.28 of y is equal to 8. Did you follow me? I hope so. If you have any questions, feel free to email your instructor at any time. Now we can solve this system in the same way that we've done before. Each time I'm going to use substitution on all these types of mixture problems. So from equation 1, I'm going to get that x is equal to 32 minus y by just subtracting y from both sides. Okay, that means then if I substitute into equation 2, I get 0.16x plus 0.28y, but not y and not x. Actually, I meant 0.1632 minus y. That's what I'm plugging in for x, plus 0.28y is equal to 8. One equation, one unknown. Simplify the left-hand side to solve. 0.16 times 32 gives me 5.12 from my calculator, minus 0.16y plus 0.28y is equal to 8. If I collect like terms, I have 5.12 is equal to, sorry, not equal to, but it's added to 0.28 minus 0.16 is 0.12y. If I subtract 5.12 to the other side, I end up with 0.12y is equal to 2.88. Dividing both sides by 0.12, I get y is 24. That means I need 24 ounces of the 28% alloy. Now, how do I get the X? Okay, from up here. Right, X would be 32 minus 24, or 8. So I need 8 ounces of 16% alloy, and I need 24 ounces of the 28% alloy. And that mixed together provides me with a 25% alloy at 32 ounces. Now, it's kind of interesting. I've run across this problem not in the context of a jeweler before, but in terms of a butcher. You could do the same type of question. Say you had 85-15 beef, that is 85% beef, 15% fat, and you had an extra lean cut of beef. So you had like the extra lean, which is the 96% beef, 4% fat. What combination could you combine those in so that you could get 1 pound of the 93.7, the 93% beef, 7%? You could do a combination problem like that exactly the same way. You just figure out how much of each of those components that you need. It follows the exact same pattern as this solution here. So you're talking jewelers, you're talking butchers, you're talking investment analysts. We can even do chemistry. So say we've got a solution that we need a particular acid percentage for. That's what the next problem does for us. A chemist needs to mix 12% acid solution with a 20% acid solution to obtain 160 ounces of a 15% acid solution. How many ounces of each acid solution must be used? So we set this up exactly the same way. So one, our variables we'll declare to be, let's say, X is the amount of 12% acid, Y is the amount of 20% acid. Okay, so let's now look at our equations. The total equation is X plus Y needs to be how much? We need 160 ounces, right? And since we're working in ounces, let's make sure we indicate that here up on our list. Okay. Now what about the mixing equation? Okay. Solution 1 gives me what? 0.12 of X. Solution 2 gives me 0.20 of X, of Y actually. That adds together to give me, in my final mixture, 0.15 of 160. That's how many ounces of acid would be in there. 15% of the 160 ounces. Which, if I multiply that out, that gives me 24. So what does my system look like? Looks like this. It looks like X plus Y is 160. And 0.12x plus 0.20y needs to equal 24. Now we solve the system the same way. Subtract y from both sides. I end up with x is equal to 160 minus y. Substitute that in. I get 0.12 times 160 minus y plus 0.20y equals 24. Again, all I did was solve equation 1 for x, and then I substitute into equation 2 to get this thing. Okay? Since we've done this a number of times, I kind of speed up each time I'm doing it. Feel free to pause and rewind if you need to. That we can distribute this to get the left-hand side simplified. 0.12 times 160 is 19.2. 0.12 times minus y is minus 0.12y plus 0.20y is equal to 24. Collecting like terms, I end up with 19.2 plus 0.08y equals 24. I subtract the 19.2 from both sides. Okay, so 0.08y is equal to, if you can make out that that's an 8, is equal to 4.8. Divide both sides by 0.08. Y is then equal to 60. Okay, which means x is going to be, remember, 160 minus y, so that's 100. So I have 100 ounces of 12% acid, and I need 60 ounces of 20% acid. And that gives me my final solution. Pun intended, by the way. Alright, last thing we want to do is take a look at a couple business applications here. Actually, just one example, but we're going to do it by introducing what's called the revenue function, cost function, and the profit function. We're not going to use the profit function here, but we will later on. I just want to make sure that you're familiar with these concepts. I think most of you probably are. And then how we might use that to determine where the break-even point is for a particular analysis or word problem. The revenue function, if you're in business and you sell a product, the simplest type of revenue function that you might have, it just measures how much money is coming into your business, right? So let's say you have a single product, you set that price, and you sell so many of those. If the variable is the number of objects that you produce and sell, then the revenue is going to be this function right here. R of X is going to be the price per unit sold times the variable, times the number sold, right? So if you sell something for $3, then your revenue function would be 3x because it's 3 times every one that you sell, right? Cost function, the simplest type of cost function would be how much it costs you per item to make, but a little bit more interesting and more common cost function would be to break down your cost into 2 different sets, because most, even the simplest type of business is going to have a set of costs called fixed costs, meaning that that's going to be how much it costs to set up shop to begin with, right? Doesn't matter how many you sell or how many of the product you have to make, you've got a fixed cost. Okay. Plus, then you may have a cost per object sold. So, like if you're making shoes, you've got to buy not only a facility to build your shoes in, that would be a fixed cost, but you then have to purchase the materials, and the amount of materials you purchase depends on how many objects you're going to produce and sell. So there is a fixed cost plus a cost per unit, and then your cost function would look like your fixed cost plus how much per unit produced times the number that you're producing. And then your profit function obviously is how much you bring in minus how much you have to spend. So that is profit is revenue minus cost. The break-even point is going to be when your profit is 0. You see, when you start a business, generally you're going to have, if you're looking at this very simple model of a business structure, you've got a certain amount of cost you have to invest, and you're going to be behind for a while. That is, you're going to be in the hole when you start, and then as you begin to bring in more money, then at some point, hopefully, if you've got a good business plan and a good product that people are buying, then you're going to break even at some point and then begin to make a profit. So let's consider the very simple example of starting a business writing greeting card. You invest $30,000 to start your business. The supplies cost 2 cents per card, and you're selling each card for 50 cents. So in solving this exercise, let's let X represent the number of cards produced and sold. So let's identify our cost function. Right? What is C of X? Remember, it's going to be fixed costs plus cost per unit times X. Now, what is our fixed cost in this problem? Well, it's the amount that we're investing to begin with. That's the $30,000. So that's your fixed amount. And then how much does it cost you per card? Well, they give us 2 cents. Now, since this 30,000 is in dollars, cents would be 0.02x. There's your cost function for this business. Now, what's the revenue function? Revenue function is going to be the amount we bring in. Well, we know that we're going to sell the card for 50 cents, so there's your price. And your revenue function is price times X, right? In this case, that's going to be 0.50 times X, 50 cents times X. Make sure you keep the units the same in both of these. Generally, dollar units is fine, but for larger businesses, you might consider using thousands of dollars or hundreds of thousands of dollars in this kind of situation. Although, to be honest, if you're in a business making hundreds of thousands of dollars, your revenue and cost functions are probably going to be a little bit more complicated than these basic simple examples, but we got a place to start. Okay. Now we are asked to determine the break-even point, right? The break-even point is when the profit is equal to 0, or another way of thinking of it is when your revenue is equal to your cost. Okay, so set these two functions equal to each other. So I'm substituting them into this equation right here. Okay, so that would mean that I would have 0.50x, the revenue, needs to equal how much it costs. So 30,000 plus 0.02x. How many cards do I need to produce and sell in order to reach that point where I've paid off my investment plus my costs to get there? So to do that, I'm going to solve this equation. To solve it, I just need to get x by itself. So I subtract 0.02x from both sides, which gives me 0.48x equals 30,000. Divide both sides by 0.48, and I get x is 62,500. And of course, that's in cards, since that's the business we're in. I would need to produce and sell 62,500 cards in order to break even. All right. Okay, that's the end of section 3.2.